All right, well, hello, seventh grade. This says use a tree diagram to find the sample space and the total number of possible outcomes. We are continuing here in chapter 7 about probability. So we're going to be looking at some different things today. One of them is going to be tree diagrams, sample spaces, as you see. So here's an example we're going to do here. Use a tree diagram to find the sample space and the total number of possible outcomes. Well, first of all, let's say you're planning a birthday party. And the options that you have are ice skating, sledding, and laser tag. So if you're going to make a tree diagram, you're going to come up here first, and you're going to write out those three options. Ice skating, sledding, and laser tag. So there's the start of your tree diagram. Now, with each of these comes a possible time frame. You could do either one from either 12 o'clock to 2 o'clock p.m., from 2 o'clock to 4 o'clock p.m., or from 4 o'clock to 6 o'clock p.m. So I come over here, ice skating. Well, I could do ice skating from 12 to 2. I could do ice skating from 2 to 4. I could do ice skating from 4 to 6. I could then do sledding from 12 to 2. I could do sledding from 2 to 4, or I could do sledding from 4 to 6. Or I could choose to do laser tag from 12 to 2, laser tag from 2 to 4, or I could do the laser tag from 4 to 6. Now we want to create our sample space. We want to create our sample space with all the possible outcomes. So typically they would write it right over here, but for space reasons, I'm just going to come down here. So we see that we could have ice skating. Okay, so I'm just going to, for time's sake, abbreviate it with skating. We could have skating, 12 to 2, skating, 2 to 4, skating, 4 to 6, okay? And then we'll look at sledding, 12 to 2, sledding, 2 to 4, sledding, 4 to 6. And then you could have laser tag, 12 to 2, laser tag, 2 to 4, laser tag, 4 to 6. All right? And so that would be your sample space. But then you need to find the total number of possible outcomes. Each of these is an outcome. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 possible outcomes that you could have in that scenario. All right? Let's look at the next one. The next one, when finding probability of events, is what we call the fundamental counting principle. And this says use the fundamental counting principle to find the total number of possible outcomes. Well, let's say you were going to a restaurant for lunch and you were ordering some French fries, or you wanted a snack or something. Well, when you use the fundamental counting principle, this is a very straightforward way, and it involves some multiplication. Well, first of all, when you go to the restaurant, you can order 3 sizes. You can order small, medium, or large. So that's 3 possibilities there. Then this particular restaurant had 4 types of French fry offerings, just regular French fries. You could also get curly fries. You could also get waffle fries. You could also get the spicy Cajun fries if you'd like. So we got regular, curly, Cajun, waffle. That's 4 possible outcomes. Then all I do is take these 2 numbers and multiply them together. I do 3 times 4. Well, 3 times 4 is 12. That is using the fundamental counting principle to find the total number of possible outcomes, okay? And so that is pretty straightforward there. All right, the last part, and we're going to pull out my paper here, as once again we're out of boardroom. This is finding the probability of a compound event. And by a compound event, I mean there's separate things happening, multiple things happening. So here's what the directions say. And we've got 3 examples that we're going to look at. It says you spin the spinner and roll a number cube. Find the probability of the compound event. So this is what you're doing. You're spinning the spinner right here. Now, once again, Mr. Swack's great drawings here. We have a spinner. It's a perfect circle. All sections are the same exact size. So it's equally likely that any one could be landed upon. And then you rolling a number cube, like if you're playing Yahtzee or Monopoly, a dice has 6 sides, 1 through 6. So we have 6 possibilities there when we roll a number cube. Find the probability of the compound event, spinning a composite number and flipping tails. So first of all, when we spin the spinner, we want to realize that there are 5 possible outcomes. 1, 2, 3, 4, 5. When we roll a number cube, like a dice, like we said in Monopoly or a dice game, those are numbered 1 through 6, so there are 6 possible outcomes there. That means that when I spin the spinner and I roll a number cube, if I multiply these numbers together, that tells me that there are 30 possible outcomes. And when I do the compound event, what I want is the number of favorable outcomes over the number of possible outcomes. The number of favorable outcomes over the number of possible outcomes. So I need to know that there are 30 possible outcomes. So in this particular, for the first couple, it's going to be over 30. Now, spinning a composite number, it's first of all important that we understand what a composite number is. A composite number, remember, is a number that not only can it be divided by 1 in itself, it also has other numbers that can go into it. Well, when I look at my chart, the only number that would be a composite number is 4. 1, 2, 3, and 5 are all prime numbers because they are only divisible by 1 in themselves. 4 is divisible by 1, 2, and 4. So there is only one possibility of a composite number on this spinner. So, and then flipping tails, okay? Not sure why we have flipping tails, but we're going to change that. We're going to say, I'm not sure why I have that, but we're going to say, and rolling a 4. All right, well, I guess we're going to have to change these. I did these with flipping a coin. Sorry about that. So spinning a composite number and rolling a 4. Well, a composite number would only be 4, so that's 1, and then rolling a 4. So there's only one possibility there, and that's rolling actually that's spinning a 4 and rolling a 4. That's only one possibility of a favorable outcome, which means that my probability of this compound event, since there's only one favorable outcome and 30 possible outcomes, it's 1 over 30. I'm going to have to change this second one too. Spinning an even number and rolling a 1 or 3. All right, so we're going to change that up again. Sorry about that. So spinning an even number and rolling a 1 or a 3. Well, if I go to my spinner, my even numbers are 2 and 4. So that's 2 possibilities. Then I can roll a 1 or a 3. That's a couple of different possibilities. So I want to see what my favorable outcomes is. Well, first of all, I could spin a 2 and then roll a 1. That would be a favorable outcome. I could also spin a 2 and roll a 3. That would be a favorable outcome. But I could also spin a 4, because that also is an even number, and roll a 1. And that would be a favorable outcome. I could also spin a 4 and roll a 3. That would also be a favorable outcome. That gives me 1, 2, 3, 4 possibilities. 4 favorable outcomes over 30 possible outcomes. Well, as a 7th grader, I need to realize this is not in simplest form. These are both even numbers. They are divisible by 2. 4 divided by 2 is 2. 30 divided by 2 is 15. In simplest form, it's 2 over 15. And so the probability of that compound event is 2 out of 15. All right, now this third one we're going to look at is something a little bit different. Once again, we were using flipping a coin. I'm not sure what I did there in my preparation. My bad. Okay. And we're going to say not spinning an odd number is what we're going to call it. Or not rolling an odd number. All right. So here we have a little situation where we're spinning a 5, then not rolling an odd number, and then spinning an odd number. So we're spinning the spinner, we're rolling the number cube, and then we're spinning the spinner again. Okay? So once again, we're spinning the spinner. There's 6 different possibilities. Actually, sorry, 5 different possibilities on the spinner. Then we are rolling an odd number on the number cube. There are 6 possibilities there. Then we're going back to spinning an odd number, and there are 5 possibilities there. Okay? So we do this multiplication, 5 options on the spinner times 6 options on the number cube, that's 30. 5 times 6 is 30. Times 5 options on the spinner again, because we're spinning the spinner a second time, equals 150. So that's my number of possible outcomes here in this third example. And you're going to have a section on your assignment where they kind of do this again. They spin the spinner or flip the coin or whatever the case is again. So now I need to figure out what the possible outcomes are. Well, first of all, I know I have to spin a 5. I'm going to spin a 5, and then it says rolling not an odd number. So that means it has to be an even number, which means on my spinner it has to be either 2 or 4, because it says not an odd number. So I could spin a 5, okay, and then I'm rolling not an odd number. So I'm rolling it on the number dice, rolling not an odd number. That's going to be either 2, 4, or 6 because of my number cube. It's going to be either 2, 4, or 6. So I could spin a 5. I could then roll a 2, and then I spin an odd number. Spin on the spinner, either a 1, a 3, or a 5. Okay? So spinning a 5, not rolling an odd number, I roll a 2, and then I spin a 1. That would be an acceptable option. Well, then I could spin a 5. I could roll a 2 again, and then I could spin a different odd number, which would be 3. Then I could do this again. I could spin a 5. I could roll a 2, and then I could spin a 5. And I think you start to see what happens here. But I'm always spinning a 5, so once again I'm spinning a 5, but I'm rolling not an odd number. So I may not always roll a 2 here. I could possibly roll a 4, because that's not an odd number on the number cube. Then I could spin an odd number, and I could spin a 1. Then I could spin a 5. I could roll a 4, and I could spin a 3 on the spinner. Well, then I could spin a 5. I could roll a 4 on the number cube. In spinning an odd number, I could go and spin a 5 again, since a 5 is an odd number. But then I go back, and I could once again spin a 5, roll not an odd number. Now, I've already used 2. I've already used 4 with spinning an odd number here. But I could also roll a 6, as that is not an odd number. Then I could spin a 1. I could roll a 5, spin a 6, or spin a 5, roll a 6, spin a 3. Then I could spin a 5, roll a 6, spin a 5. And that exhausts all of my options. Okay? So I see that I have 9 different favorable outcomes, which leaves me with 9 over the 150 possible outcomes. Well, if I see 15, I can easily see that these are both divisible by 3. So it's not in simplest form. 9 divided by 3 is 3. 150 divided by 3 is 50. In simplest form, it's 3 over 50. And that would be the probability of that compound event. All right, my apologies for the confusion on the last part, but I think we made it through. All right, talk to you later, 7th grade.